Hello and welcome. I'm Lior. I'm joined by my partner Lior. We gladly present our 3D maze Java project. In our project, we have been asked to generate a 3D maze using BFS generating algorithm and solve the maze using BFS and A-star algorithms. As you can see, A-star algorithm is using heuristic to estimate the distance between the current state and the goal state. This allows the A-star to be the most efficient search algorithm in its category. In our project, we use client-server architecture. The client's model sends over TCP/IP a request. The server then executes the request and checks if the result is already in the database in order to save time. Elsewise, the server calculates the result and saves it in the database using Hibernate ORM. Finally, the server sends back the result to the client. As a team, we wanted to work in parallel to each other, so we used MVP architectural pattern. MVP divides the code into three layers: the model, the view, and the presenter. The presenter links between the view and the model, so they wouldn't need to know each other's implementation. Let's demonstrate. First, let's open the server. We can see here red messages. Those red messages are from Hibernate, which tells us he's trying to connect to the database and succeed. Server is on. Now let's open a couple of clients. Client number 1, client number 2. Okay. Now let's first take a maze from the database. You can see here the table. We get name, maze, and solution. Let's take maze first. Open first. Get maze. And let's generate a maze. Second. Side 656. Generate maze. We get a pop-up which says the second is ready. We can see here the player, the walls, and the goal. We can change cross-section to get a different perspective of the maze. We can change the algorithm of solution. Let's solve the maze using BFS. Solution is ready. Here is the first step, and here you can see another. Now here let's get a hint using A-star distance. Here is the hint. Now let's solve the maze. You can move left and right using the arrow keys, and up and down using the up and down keys, and move between layers using page up and page down. Here I try to walk into a wall, so we get a message that he can't move there. And now we won. Let's exit and exit here also. Okay, let's open another one. Let's create another one. It's called big because it's gonna be big. 20, 21, and 21. Generate. The maze big is ready. Now here we can see that we can barely see the character, so we can zoom in and zoom out. We can also move a little, and the zoom in, zoom out follow. We can restart, move to the start, and set the properties, the server port, and the interface. Let's put CLI, and the IP. Let's put my computer's IP, and save the changes, and let's exit. Now let's open CLI. Here you can see the CLI, not much different. We can generate, we can solve, but let's exit for now. Now let's close the server, and the server is off. Here we can see that the server is terminated, the big maze is terminated, and we had here two processes that has been terminated too. Now, let's review our code. The client and the server are both using MVP architectural pattern. To do that, we used observe pattern. The server uses thread pool in order to maintain a maximum number of clients it can handle at any moment. Also, the server uses client handler, a class we made. This class let the server be as general as possible. BFS is very similar to A star. The only difference that A star has heuristic in comparison to BFS. So, in the code, the only difference between BFS and A star would be the comparison. In order to do that, we created two classes, one for BFS and one for A star. The A star would inherit from BFS the search algorithm and override the comparison methods. That's all. Thanks for watching, I hope you enjoy, and goodbye.